Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that's fundamental to your energy, clarity, and overall long-term health: detoxification. When we talk about detox, we're not talking about trendy juice cleanses. We're talking about a continuous, complex, and vital process happening every second inside your body, primarily in your liver. And here's the fascinating part. Your genes determine how well this process works for you. Understanding your unique genetic blueprint for detox is the ultimate form of personalized wellness. Let's break down the key genes and pathways involved in keeping you clean on the inside. Before toxins are processed, your body needs the right components, and that's where methylation comes in. Methylation is a critical biochemical process that affects DNA repair, neurotransmitter production, and, yes, detoxification. Think of methylation as the engine of your cell's support system. One of the most famous detox-related genes is MTHFR. This enzyme helps your body process folate, which is a super important nutrient. If your genetics indicate a lower MTHFR activity, your ability to methylate, or essentially process things, may be lower overall. This predisposes some individuals to lower methylation ability. Other methylation genes like SHMT1 also influence this process. For some, having certain SHMT1 genetics might mean they favor the folate cycle over the main methylation cycle, impacting the production of active folate. We also look at genes like TCN2, which is crucial for the uptake and transport of vitamin B12. Why is that important? Because B12 is a key cofactor for converting toxic homocysteine back into methionine in the methylation cycle, meaning lower TCN2 activity can potentially lead to higher homocysteine levels. If your methylation pathway is struggling, it can create backlogs, impacting everything from cardiovascular health to mood regulation. Now, let's talk about the main event, the 2 phases of liver detoxification. Phase 1, the activation stage. Phase 1 enzymes, often called the CYP or cytochrome P450 enzymes, start by chemically modifying fat-soluble toxins. They essentially activate them, making them more reactive and ready for the next stage. Genes like CYP1A2 and CYP1B1 are active here. CYP1A2 is famous for breaking down caffeine. If you have a higher CYP1A2 activity, you might be a fast metabolizer who feels less sensitive to coffee. But remember, high activity means fast processing of toxins too, which can create those tricky, temporary toxic intermediates. In some cases, like with CYP1B1, higher activity might increase the production of toxic metabolites from hormones and other substances. Phase 2, the conjugation stage. Phase 2 is where the magic happens. Enzymes bind a small, water-soluble molecule, like a wrapper, onto the activated toxins from phase 1. This conjugation step renders the toxins safe and ready to be excreted in urine or bile. Key phase 2 players include GSTP1, which uses glutathione to eliminate oxidative stress products and toxins, and SULT1A1, which is crucial for processing chemicals found in cigarette smoke and well-done meat. Then there's NAT2. This gene determines your acetylator status. If you're an intermediate acetylator, your body detoxes certain substances like specific drugs or even environmental toxins from cigarette smoke at a moderate pace. This balance is key. Every time phase 1 fires up, it generates oxidative stress. So detoxification is always paired with your antioxidant defense system. The SOD2 gene creates an enzyme that is a major player in reducing this internal oxidative stress. If you have lower SOD2 activity, your body's ability to neutralize these free radicals might be reduced, increasing your need for dietary antioxidants. And finally, a crucial component that influences everything we've talked about is alcohol sensitivity. Genes like ADH1B and ALDH2 determine how quickly you break down alcohol to the toxic acetaldehyde, and then how quickly you clear that acetaldehyde. For those with genetically higher sensitivity, acetaldehyde builds up more quickly, which is why they may need to limit alcohol intake. This knowledge isn't meant to cause concern, it's an invitation to take action. If your genetics point to specific bottlenecks, you can tailor your lifestyle. For lower methylation capacity, increase dietary folate from leafy greens like spinach and asparagus. Also consider methylfolate or betaine TMG supplementation to help bypass reduced enzyme activity. To support antioxidant defenses, focus on foods rich in glutathione or supplements like N-acetylcysteine to help boost your body's own production. Your detox system is incredibly powerful, and understanding your genetic code unlocks the blueprint for optimizing it. If you found this breakdown helpful, hit that like button and subscribe. What part of your genetic health do you want to explore next? Let me know in the comments below.